Well, thank you very much, Ken and Nancy. It's great to be with you again. Some years ago, I talked very specifically about my adventure on the moon, and you'll get some of that tonight. You already had plenty. My first visit to Pensacola, I think, was in survival training. We experienced the dumpster that puts you in all sorts of weird orientations underwater. You're supposed to figure, I see some heads nodding. And then the next time was to learn to fly H-13 helicopters. And they told me I was going to do a solo in 8 hours. Now, I'd already learned to fly T-38s, and it took the Air Force about a year to teach me how to fly a T-38. And I said, you've got to be kidding, 8 hours? Ain't going to happen. Well, it did, and I tell you, the Navy trainers down here just did, and I'm sure do, a magnificent job still. What we're going to do tonight, though, is to try to put into context the adventures that you heard a little bit about on the moon into a historical context that goes back, you can go back forever in the history of technology, but I'm going to begin with the Wright Brothers. But first, I want to see how many nerds there are in the audience. You got to think about this one a little bit. See? Takes a while. Okay. Let's also review quickly just what the Apollo space program was all about. Most of you, I'm sure, are historically literate enough to remember that landing on the moon was first proposed by President Kennedy in 1961, mid-year. It was obviously, and we have to remember this, it was not a scientific program. It was made a scientific program by some very far-thinking people in NASA, such as George Low and others. But it was to counter the Russian, then Soviet advances in human spaceflight. It was part of, and this is important, it was a very important part of the competition that existed within the Cold War. And this was, as you recall, John Glenn was the first American to orbit the Earth after Alan Shepard and Gus Grissom's flights in suborbital space. Apollo 8, we forget about Apollo 8 sometimes, but orbited the moon in December of 1968. And beginning with that mission, I just remind you that for the next 12 months, we were launching Saturn V rockets every 2 months. Saturn V rockets. You'll hear more about that in a moment. Really a remarkable period, and that, and then finally, many would say that the space race ended with Neil Armstrong successfully landing on the moon on July 20th. That, many of the people, though, who experienced Apollo 8 really felt that that was the end of the space race. It was a remarkable, it was a mission that we never expected to fly. George Low proposed it. 4 months later, we flew it. And it was that kind of an environment. Young men, and mostly, but young men and women working as teams were just doing remarkable things. They didn't know how to fail, and they didn't. Now, there were 5 additional Apollo missions after Neil's landing that landed on the moon between November of 1969 and December of 1972. Those, of course, there was Apollo 13 in the middle of that, that was damaged by an explosion of an oxygen tank, but where the crew was rescued almost entirely through the remarkable work of the mission control team in Houston, and the contractors that were supplying them with the information they needed to make that possible. Now, the last 3 Apollo missions, the last of which I was privileged to be a member of, each explored different areas of the moon, and for full 3 days, in contrast to the very short 1- and 2-day missions that had been preceded it. The total return, scientific return in terms of sample weight from the Apollo missions was 850 pounds of moon rocks, and of course soil that was brought back to Earth. Those samples are still being studied today. I don't know how the studies are being paid for, and I don't ask. But in March of this year, we'll have, I think it's the 46th Lunar and Planetary Science Conference. And I'll guarantee you there'll be several days of papers presented as a result of continuing work on these lunar samples. I myself still work and publish and try to synthesize some of the more detailed work that's being done. The primary return, number one, from a geological perspective, is an understanding that we never had of the early history of the Earth. The moon has been a recorder, a library, if you will, in space almost as long, if not as long, as the Earth has been in orbit around the sun, that has been recording the environment of near-Earth space, and particularly the impact environment. And it was an extraordinary violent time in the early history of the Earth, a history that's been obscure to us as a consequence of geological activity here on Earth that continues. Volcanic activity, you've heard of subduction of continents and things like that. That has pretty well made it impossible to see so far geologically back beyond about 3.5 billion years ago. And you heard that number a little while ago as the age of a relatively young material on the moon, 3.5 billion. However, that's when the moon's history starts that we have been reading as a result of Apollo. So it really has been a remarkable time in the history of the Earth sciences. Now, let's go back now and look at what the Wright brothers did. December 17th, 1903. This is when humans first experienced powered flight. They had been gliding flight for many years before, balloon flights before that, but actually powered controlled flight began December 17th, 1903. And on May 25th, 1961, John Kennedy then challenged the Congress and the nation to support landing a moon on the Earth, landing on the moon before the decade of the 1960s was complete. And of course, he also mentioned bringing them safely back to Earth, which was nice. I had one volunteer that came specifically to me and said, NASA's making a big mistake. I will go, and I don't care if I don't come back. That volunteer was Harold Urey, Nobel laureate Harold Urey. And I think he meant it. In fact, I know he meant it. But let's ask what happened between 1903 and 1961 that would lead President Kennedy, NASA, and the Congress to believe that the United States could actually accomplish a moon landing. Well, one of the things that happened was Robert Goddard. And in my home state of New Mexico, he began launching rockets. On the left, you see there the rocket he first launched in Massachusetts, and I probably shouldn't say this, but typically they kicked him out and he came to New Mexico. These experiments were the first in successful experiments with liquid fuel rockets. And of course, that's what a Saturn V was. It was a liquid fuel rocket. And it led to all sorts of things. Here you see a bunch of gentlemen engineers, some in ties. Ken Ford, you should maybe make it a requisite that engineers wear ties again. Of course, then they'll get caught up in robot mechanisms, and maybe that's not a good idea. At any rate, this is a bunch of them holding one of the rockets that they used. One of the signs of Goddard's farsightedness is this blackboard picture that I discovered. And if you look carefully, there's some things there. For one thing, he got the moon on that blackboard. That's what he was thinking about. And he even has almost the right calculation for the escape velocity necessary to get there. So we're very proud of Robert Goddard. Now, pre-1945, a lot of things happened. We had the demonstration of human aircraft flight, powered flight. There was 30 years of engineering and tests by the National Advisory Committee on Aeronautics, a little known but extraordinarily important organization, NACA. They were the precursor to NASA, and we'll talk a little bit more about that maybe later. Robert Goddard's liquid fuel rocket launch in 1926, and rapid advances in aviation physiology, and in rocket science in general, primarily through U.S. Army and Navy rocket engineering, but an awful lot of private entrepreneurs were working during that time. The first entrepreneurs really in aircraft were the Wright Brothers, because they were trying to sell the Wright Flyer. And in fact, they started to sell it, both in Europe and in the United States, particularly to the Army. Now, between 1945 and 1956, the technology base for everything that we would do later began to solidify. The Cold War had a great deal to do with that. Eisenhower's order to rescue von Braun and his team from Peenemünde certainly was extraordinarily important. That formed the Army Ballistic Missile Agency in Huntsville, Alabama, with an adjunct in New Mexico, I might say, where they were launching. When I was 11 years old, I was watching contrails of V-2s being launched out of the White Sands. One of them ended up in Taurus-Littrow, Mexico, which was some very black headlines for a while. There were defense-related electronic development going on all the time. This is one of the V-2s being launched out of White Sands. And between 1957 and 1960, you see these time frames are getting compressed. Things are really starting to move. Sputnik 1 became the first artificial satellite of the Earth. I happened to be in Norway at the time as a Fulbright student and heard about that over with an interruption of Willis Conover's Jazz from A to Z. Anybody remember Willis Conover? He was on The Voice of America. It was about 11 o'clock every night after I got in from the field. Of course, the days were very long in that latitude. I would listen to that and sort of unwind. Now, Eisenhower, Johnson, and McCormick and Teague made an agreement after Sputnik that one, they would form NASA, and that NASA would be civilian-led rather than military-led, such as was the case in the Manhattan Project to develop the first atomic bomb. That was probably a very, very important decision on Eisenhower's part, and one of many he made in this arena. That was to keep 3 independent strategic missile developments, and that still today forms the basis of the triad that protects freedom throughout the world, really, and particularly in the United States. Eisenhower appointed T. Keith Glennon and Hugh Dryden to lead NASA. Dryden came out of the NACA. He had been the leader of the National Advisory Committee on Aeronautics. Glennon from Case Western, I believe, University out of Ohio. 2 very, very remarkable individuals. If you like to read diaries, I strongly recommend Glennon's diary. Diaries are extraordinarily difficult to read, and my suggestion is that you get a copy you can color code by subject, and then you can start to piece this thing together. But one of the things that was Eisenhower also did was to transfer that NACA, JPL, which was an Army organization, the Jet Propulsion Laboratory, and the Army Ballistic Missile Agency to NASA. Well, things went pretty good until the Army started to drag their feet on transferring the Army Ballistic Missile Agency and von Braun to NASA. And Eisenhower actually finally, it took about a year, finally as president, had to put his foot down and tell the Army, you're going to do that. And that became the Marshall Space Flight Center. And also the Kennedy Space Center was derived from that, because that was originally the launch facility for Marshall. there also in that period of time was formed the Gilruth Space Task Group. These Bob Gilruth, Chris Kraft, George Lowe, Max Faget, these names may be familiar to some of you. They were all part of that. They came out of the NACA. They had worked complex engineering projects. Nothing as complex as Apollo, but still they knew how to manage these complex projects. Extraordinarily important foundation to have. And these were relatively old folks, maybe in their 30s and 40s. But they had under them people in their 20s. And that was probably one of the most important, if not the most important ingredient of Apollo, were these young Sputnik generation engineers that came into NASA and made it all happen. They were courageous, they were motivated, patriotic, and just did a remarkable job. My experience working with them as a relatively old 30-year-old is just one of the highlights of my life, no question about it. During that Space Task Group had been working had initiated the Project Mercury, which is the first manned in space program, again, still in the Eisenhower administration. And the X-15 was also inherited from the NACA. That X-15, again, that was a complex rocket program, rocket aircraft, that gave a great deal of experience to these engineering cadre, as well as training a few people like Neil Armstrong and Joe Engle and others that were an important part of the Apollo program. The F-1 engine, which was under development by the Air Force, was transferred to NASA from the Air Force. There's an F-1 engine. 5 of these powered the first stage of the Saturn V. So you can see that during this period in the Eisenhower administration, a great deal was happening that ultimately enabled the success of Kennedy's challenge. Industry and NASA had put together a number of design studies in the 1959-1960 period, one of which was George Lowe's study, detailed study of a lunar orbit mission, which ultimately became his proposal for Apollo 8. Now, Eisenhower could claim responsibility for initiating the development of the Saturn V, or what was then known as the Superbooster. Here you see a picture on the left of von Braun demonstrating one version of that early booster to the president. Now, January-March 1961. George Lowe's Manned Lunar Task Force was established, which included that mission around the moon that I mentioned. Johnson became vice president with the space portfolio in the Kennedy administration. Webb was appointed NASA administrator with Dryden continuing as his deputy. Again, a very important set of decisions. Webb being much more of a manager than a technologist, but an excellent manager. And in March of that year, Gilruth apparently met with Kennedy privately. I'm still trying to verify that. I think that probably did occur, and it had a lot to do, I think, with Kennedy beginning. Remember that this was several months before Kennedy made his announcement, but Kennedy starting to become comfortable with the idea of the Apollo program. Here you see some of those people I just mentioned. Kennedy, Vice President Johnson, Bob Gilruth, prominently near the podium. Now, May 1961, we had, on April 12th, Yuri Gagarin's orbital flight, which just solidified the concern, national concern, that had been brought about by Sputnik. That's the launch of Yuri Gagarin from Kazakhstan, I believe. The Bay of Pigs occurred, which may or may not have had a catalytic effect along with the flight of Gagarin. Kennedy held a press conference in April 1921, in which he alluded to that if we could go to the moon, we probably should. But he hadn't made a formal announcement of it. Now, Johnson played an important role at this point, Lyndon Johnson, by forcing Webb and Wiesner to get around a table and agree that the moon landing was going to be what the objective would be. Lyndon Johnson apparently had a great facility for getting people to agree to things. Webb then briefed Johnson on the feasibility based on the low Lunar Task Force. Shepard made his suborbital flight in May 5th. There's getting a greeting from President Kennedy. John Glenn, the next year, just threw this picture in to show he was demonstrating the capsule, the Mercury capsule that he took into orbit. Now, Webb and McNamara, though, on the 6th of May, agreed that NASA should lead the moon era. That for a while there was still some competition, bureaucratic competition of whether it shouldn't be a defense-led program or not. McNamara finally agreed that NASA should lead it. Webb that evening drafted a decision memo that was presented to President Kennedy, and Kennedy apparently accepted that decision memo without amendment, without change. And on the 25th, as we already have noted, Kennedy addressed a joint session of Congress. Now, what came out of all of this, of course, was the Saturn V and the spacecraft that would be nestled in its apex. Now, I put Goddard's first successful, or one of his successful liquid fuel rockets on the right. That's a little bit misleading in terms of scale. It wasn't very big. Just to give you another idea of scale, there's a very large fire truck right there. This vehicle assembly building, or the VAB, it always sounded like a soap factory to me, but at the time was the largest enclosed space on Earth. Since been eclipsed, I'm sure, by a number of things, certainly the Mall of America in Minneapolis, but also I think the 787 assembly plant in South Carolina is now significantly larger. Well, in the early part of 1969, the selection process was going forward, principally in the mind of Deke Slayton, my boss at the time, of who was going to be the first crew on the moon. And here you see that crew, I believe, very anxiously awaiting the acquisition of signal from the Apollo 8 spacecraft as it came around the moon in December of 1968. Mike Collins, Neil Armstrong, and Buzz Aldrin. Ken Mattingly, some of you may know Ken. He's there. Yours truly also looking somewhat concerned at the time. That acquisition of signal would come at a very precise moment and would tell you whether or not the burn from behind the moon had been successful. So that's why we were looking likely. If it hadn't come at the right time, we would have really been concerned. Oh, I should also mention, exactly the same thing happened with Apollo 10, which was a test of the lunar module in orbit around the moon. Not a landing, but a test of the lunar module. Tom Stafford was commander, and Gene Cernan and John Young were the crew. For this particular moment, the viewing room, semi-public viewing room in the Mission Control Center was absolutely jam-packed. Well, you can guess, for Apollo 10, there wasn't anybody in the viewing room. You'd done that. We're Americans. We did that. Now let's get on with what needs to be done. And it really struck me as a very interesting commentary on the engineering culture of the time. Well, they're the two spacecraft that the Lunar Module and the Command and Service Module. The business end of the Saturn V. And they really were remarkably well constructed. The Grumman Aircraft Corporation, which many of you are familiar with, was responsible for the Lunar Module, and North American Rockwell was responsible for the Command and Service Module. Many hundreds of subcontractors, of course, were involved in this. In fact, I don't know whether you've heard, but the total number of Americans, mostly Americans, there were a few Canadians, a very important aspect of the program, but the number of people totaled about 450,000 that were involved in Apollo. Only 50,000 were government employees. So most of them were contractors and subcontractors. It was, and I think that's one reason we were successful, was the way that responsibility was divided among the public and the private sector. Well, that's Neil Armstrong's rocket taking off from the Kennedy Space Center in July of 1969. And this is probably the only photograph of Neil Armstrong on the, outside the spacecraft on the moon. There is one of him in the spacecraft. Now what Neil is, that's because Neil said, I want to have the camera. Neil kept the camera. So all the pictures you see are of Buzz Aldrin, which probably doesn't bother Buzz at all. But in this case, Neil was collecting samples, putting them in the rock box, so he must have turned the camera over to Buzz. Buzz finally took a picture of Neil on the moon. The rock box, which Neil's working with right there, already contained at this point a large number of very well-collected, diverse samples of the basaltic rocks at the Tranquility Base. Neil told me later that he looked at that box and it looked empty to him. And so he started shoveling lunar dirt into the box and filled it up. And that was a moment of genius from a geological perspective, because that's, and possibly an economic perspective, because that sample is the sample that gives us the most information about the resources that are going to be available to some of your grandchildren or when they actually do settle the moon. Not only energy resources, some of which might come back to Earth and be useful here, but from the point of view of the settlers of the moon, oxygen, hydrogen, and nitrogen, and from the oxygen and hydrogen you can always make water just about anywhere on the moon. So that sample is sort of the holy grail of those of us who think that there is an economic rationale for returning to the moon. Apollo 11 landed south of Apollo 17. That distance there is about 600 kilometers, as I recall, and both of them near the edge of some fairly large lunar basins. This is the Tranquilitatis Basin. This is the Serenitatis Basin. Serenitatis Basin is about 740 kilometers in diameter. These are big basins. And I'll take you back for a moment to what I said about the early history of the Earth. These basins were forming between, certainly between the origin of the moon, which was probably about 4.6 billion years ago, and about 3.7 billion years ago. They also were forming on Earth. And it was during that period of time that we see the beginnings of the first fossils on Earth. So life was trying to get started down here about that time, at the same time an extremely violent period in the history of the solar system. We didn't know that before we went to the moon. We didn't know those ages, didn't know when all that happened. It was generally believed that these were relatively young basins, and they were just wrong. Now, what you need to work on the moon, you see here, each of the missions that landed there had the same equipment. Of course, their lunar module, this is the Challenger. The last three had a lunar rover, worked extremely well. And another spacecraft that doesn't get much attention is the spacesuit. It looks sort of humanoid, but it really was a spacesuit. It had its environmental control system, it had its oxygen, its water cooling system. I'm sure you all know how we stayed cool on the moon, and that was with water-cooled underwear. Cold water cooled by sublimation of ice through a porous plug in the backpack. You could circulate it through your suit and control how cold or how warm you wanted to be with a valve just behind your right hand. And communications, everything that you think of as a spacecraft having was in this suit. It had limited life because of the consumables, for maybe 8, if you stretched it, maybe 9 hours. But nevertheless, very important enabling technology. And that water cooling, by the way, was really an enabling technology, because otherwise you would not have been able to work more than maybe an hour. I doubt if you could work that long before your body heat would have gotten overwhelmed you. Just in summary, some of the major things that we've seen from the Apollo program, of course, science is represented back here by the South Massif behind me. The technology necessary to make it all that possible is represented by yours truly in a suit. And if you look carefully, here's my companion right there taking the picture. And of course, home planet Earth, really a major part of the whole effort. And the flag of the United States showing just what a set of free young men and women can do when faced with a challenge. No question about it. Now, what are the basic keys to success of Apollo? Let's go through this quickly. There was a sufficient base of technology, as we discussed earlier. Coming from World War II and the Cold War, and these decisions that Ike made. One of the most important of which was to, in about a year and a half before Kennedy made his announcement, Eisenhower sent a personal letter to Dryden telling him to begin the development of the Superbooster. And so that started us on our way. It meant that when Kennedy made his announcement, we were well ahead of the game for reaching the goal that he had set for us at the end of the decade. There was that reservoir of young engineers and skilled workers that came out of the Sputnik generation, the World War II and the Cold War. Pervasive environment of national unease. Some of you will remember the campaign of 1960. Not only was it in the middle of the Cold War, but there was part of that campaign was a so-called missile gap that probably never existed, but nevertheless it became part of the campaign, and it contributed to that unease. The catalytic event that brought everything into focus was Gagarin's flight, building on the Soviet success with Sputnik. We had an articulate, persuasive and patriotic president, John F. Kennedy, to articulate the goal. And we had, most importantly, from a pure managerial point of view, an adequate level of management reserve in funding. The White House, the Office of Management and Budget, and the Congress all agreed to 100% reserve. Now, that's unheard of today. You can't get any reserve in a technical budget anymore. But the way that came about was Webb, probably his greatest contribution to the Apollo program, James Webb, went to his engineers, George Low and Chris Kraft and others, and asked them to independently estimate what it was going to take funding-wise to meet Kennedy's challenge. And they all came up with about an these are the then-year dollars now, about an $8 billion estimate, plus or minus maybe $1 billion. Well, what Webb did was double it. And that's what he told Congress it was going to take. And Congress stuck with him. And we used it all, believe me. I'll tell you, we needed it all, too. But those of you who may be involved or get involved in management and programs, you've got to keep trying to get a management reserve. That helps you keep schedule. When you hit the unknown unknowns, the things that nobody anticipated, you got to have a reserve to get through that and stay on schedule. And we had that in those 30 and 40-year-old senior managers like Gene Kranz and his generation. We had confident, disciplined, tough, courageous management. And they really, and all you have to do is look at the history of the Apollo 204 fire, sometimes called the Apollo 1 fire, that killed Gus Grissom and his crew, to see that they knuckled down, they learned from that, and they made it all happen after that fire. And of course, being a nice conservative Westerner, I think the working environment of liberty that we had at the time was extraordinarily important, because it meant that the decision-making levels were very tight. If anybody, no matter what level they were working on in, had a good idea, and it was a good idea, it could make it to management the next morning. It was that kind of an environment. And that's why we could launch Saturn V's every 2 months, is that you could work the problems, the teams would get together spontaneously to any time a problem and test came up or something like that. And it was just, everybody felt comfortable in moving forward with a good idea. So don't forget it. Liberty is awfully important, even in programs like this. Well, ladies and gentlemen, this picture is one I took from the far side of the moon as we were leaving it. Earthrise over the lunar horizon. It may be a picture, a view that some of young people will have in the not too distant future, I hope, as they begin that long journey to Mars. So in order to do all that, it may be time that we take another walk on the moon. And with that, I'd be happy to take any questions that you might have. Okay, how about this gentleman there? You wait for the microphone.
Thank you for a wonderful trip down memory lane.
That's what's fun. I saw lots of heads nodding.
Yeah.
That's great.
Personally, I have a hard time getting my hand around $1 billion, and even today, humans walking on the moon. And reportedly, Buzz Aldrin, when he came back, had some problems making just ordinary, everyday decisions because of all he had been through. Can you tell us, did you have any personal, mental, or spiritual advance or remarkable happenings after you came back to Earth?
I can't say that I personally had any noticeable change, other than the fact that I'd walked on the moon, and you can't change that. And people ask you questions, and you're invited to give talks and things like that. That changed. That was a change. But then again, I can't speak for anybody but myself. I think I had this adventure in context with a much broader picture than you might imagine. Possibly just because I was a scientist and I was interested in the results of what we had seen and in the work that's going on. And I also had in the back of my mind, well before the Apollo experience, of getting involved in politics at some point. And that, that carried me. So I never had a point where I said, gee, now what do I do? I had lots of things that I was planning to do. And I think that's important in any kind of endeavor where an endeavor ends. You need to have it in context. It needed to be part of a longer view of what your life or your goals may be.
Thank you.
So I had no major change. Can we get one over here? Pass the mic down.
First, I want to thank you for one of the best talks we've ever had at this institute. Thank you very much.
Well, you're very kind. Thank you, sir.
Secondly, There's a movie out, a recent movie called The Martian, and as an ecologist, I have trouble trying to believe in the authenticity. Maybe, have you ever seen the movie Martian? Can you speak on it?
No, I have not seen The Martian. I've been told I have to read the book, and I haven't read the book. I should read the book before I see the movie. But all the reports I get, it's an outstanding movie. And, anytime you try to compress, take the movie Apollo 13, which is probably one of the best movies ever made. Should have won the Academy Award. But you're compressing many days into a couple hours or less, and so they're going to make shortcuts. And in the Apollo 13 movie, the one thing that technical thing that's missing, I'll just mention it, is what two engineers whose primary responsibility was lunar module electrical systems figured out on how to trickle charge the discharge entry batteries in the command module. The command module was absolutely frozen. It was down, wasn't any power, but they figured out that there was a sensor line going from the one battery in the lunar module through some several different stages of amplifiers and other things in the command module that they could trickle charge those batteries, and they needed to do that for entry back into Earth. That didn't come out in the movie. It's never come out really in any kind of documentary I've seen about Apollo 13, but it just shows you what two people can do when they think that they have an answer to a problem. Okay, right here. And then we'll go to the back of the room. Get ready for your hands back there.
Did you have any particular emotional response at the point of the translunar injection burn? And how long did it take you before you could see the full sphere of the Earth? That's two questions. The one thing I found, and maybe this is partly because I came to piloting late in life, but I found that I was so focused on making sure that all my responsibilities were carried out appropriately for any burn, particularly, that I was supposed to manage the propulsion systems and things like that. That I was just focused on that, and then as soon as the engine starts, you're focused on making sure that the time of burn is correct. So you don't have a lot of time for your emotions to take control until it's over, and then you say, "Hey, yeah, it looked like." Write any poetry?
No. I've tried a couple times since, but none of it you wouldn't want to hear a bit of. I don't know whether some of you might remember that on the morning of my last morning on the moon, I had awakened in the middle of the night, and as a kid, I used to recite "'Twas the Night Before Christmas" or "A Visit from St. Nicholas" at various parties and stuff in Silver City, New Mexico. And I woke up, and I felt rested, and I started to go through a version of that titled "'Twas the Week Before Christmas," and all through the limb not a commander was stirring, not even Cernan, And I worked it through, and then I went back to sleep. And when I woke up, it was still very fresh in my mind, so I just transmitted it down to Earth. And if you ever go to the transcripts, you can see that original version of that rephrasing of the delightful poem. You ask another question.
Yeah.
Oh, full Earth. The only time we really saw the full Earth sphere was on the way out, because we were launched to a nearly new moon, so that meant that we were going to see a nearly full Earth. Their phases of the Earth and Moon go in opposite sequence, and so when you see that full Earth picture of that shows Africa, the full continent of Africa and Antarctica, most of Antarctica, that's the first view of a full Earth that I had time to photograph. And I did that in the context, actually, of 3 days of trying to observe and forecast Southern Hemisphere weather patterns. One of my hobbies as a kid was meteorology, and so I just took advantage of 3 days whenever things weren't busy in the spacecraft of making those observations and trying to forecast what the weather pattern would look like the next day, because the Earth, we were in what's called a lunar reference trajectory, and so the Earth was turning every 24 hours beneath us. And so I could try to make those forecasts. It was a lot of fun. Even found a hurricane nobody knew about. Okay, we got any hands back there? Way in the back.
Thanks for a good talk, sir.
Thank you.
My question is very basic, actually. Reading here, it says you were the last of 12 men to step foot on the moon. Did Cernan actually get aboard the spacecraft before you? Knowing the officers as I do, he let you be the last person?
No. No, he got off the moon last. But the reason I like to look at it that Neil Armstrong was number 1 to step on the moon, I was number 12. All right. So I'll take that to the bank. All right. Any others back there? Okay, let's try this gentleman, who apparently drives Corvettes.
After your return to the limb, after your EVA, and had the lunar dust all over you in the rocks, was there any smell to the lunar dust?
There is, and it's uniformly agreed to and mentioned by all the moonwalkers. It smells like spent gunpowder. And now it goes away, but after a few minutes. But when you first take your helmet off in the cabin after you repressurize, you smell spent gunpowder. And from a science point of view, I would say that's because the particles still have not. They've been fractured in a hard vacuum. That vacuum on the moon is space vacuum. And so there's nothing absorbed on the individual particles. There's no air or anything like that on them. And it takes a while for that to change, and it's like activated carbon, which is what spent gunpowder is right after you've shot. It's activated carbon, and it has the same effect on your olfactory sensors as gunpowder would. Now that's my story, and I'm sticking with it. But everybody thinks it smells like gunpowder. Here? Stand by.
Just one moment. Oh, I'm sorry.
I'm wondering what your most memorable moment was. Yeah, I guess in your space career, let's put it that way. And what lit your fire in the first place to become involved with the space program?
My most memorable moment you really can't define. It was a continuous set of memorable moments. I always say it's the whole experience of the flight. And you even bring into that the training part of it. I enjoyed the training as much almost as I did the flight. It was, again, it's the people you're working with that are just so outstanding, and you just feel very close to them. What got me involved was, I guess, goes back. I got to be careful I don't prolong this answer, but goes back to being in Norway when Sputnik was launched, and when I returned to Oslo and became part of that international student community again, it had a profound effect on those students from around the world. And that's what triggered my mind. I said, well, I ought to pay a little more attention to this thing called space, but I never thought about actually going. Then, I don't know why I remember, but we were, a bunch of us in Harvard Graduate School were up having a beer in our social area. And one of the fellows brought up the fact that the National Academy of Sciences this was well before Apollo, had recommended to NASA that the first person on the moon be a hard rock geologist. Well, yeah, we were all hard rock geologists, so that sounded good. And then we went on about it. Never thought about it much anymore. Turns out that was the group that made that recommendation included some very important people in the space program: Harry Hess, Gene Shoemaker, people like that who knew what they were talking about. Then, when I finally got my PhD, I was looking around for a job, and it was not a good time for hard rock geologists to find employment. And I had, after my Norway experience, I had gone out to California to look at some similar rocks out there. And Bob Coleman, who had been working on those rocks, told me I needed to go down the hall at the USGS facility there and meet this crazy guy named Gene Shoemaker, who was mapping the moon, for crying out loud. And so I did. I went down and met Gene, and he's just a remarkable individual. He can motivate you to do almost anything. And plus, there were some people there I knew working with him who already employed him. And so when I got my PhD 3 years later, I wrote Gene to see if he had any job openings. And it turns out our letters crossed in the mail. He had written me asking us if I was interested. And so I went out to Flagstaff to work, and a few months later, NASA asked for volunteers from the science community, engineering community, for the first group. It would be Group 4, and they were the first group of scientist-astronauts. And so I thought about 10 seconds and said, and raised my hand, count me in. I think primarily because if there was an opportunity to do this, I would probably have regretted the rest of my life not taking advantage of it. Right place at the right time. Mm-hmm. Oh, we have a young man back there. We'll get him in a minute. Let's take one more here, and then we'll get you. Okay.
Thank you. As we approach, coming up on 50 years since that first time on the moon, what's changed in these several decades that we haven't focused? We focused on Mars for quite a number of years now, trying to get habitable things happening there. But what do you think has changed that we haven't done more on the moon in terms of, is it politics or
yes.
Just science shifts? Yeah.
No, I think you have to, that's why I emphasized early on the importance of the Cold War. It was the Apollo program was part of the Cold War. It meant that the country was motivated to do something that was going to contribute in a positive way to potentially to success in that war, and it kept our focus for a long period of time. But then the media couldn't figure out how to keep covering successful missions, and if we'd had a few more accidents, maybe we would have gotten a little more. But and when media loses interest, politicians lose interest. And so that was beginning way back in the Johnson administration with that decision to only buy a limited number of Saturn V's. Those kind of decisions just show that there is a lack of long-range perspective in most of the people that we elect to high office. They get wrapped up in the day-to-day activities that they think are required to stay reelected. And that happened to the space program. Now, is there a comparable situation today? I think there is. I think the international situation is dicey enough that a leader like Eisenhower and/or Kennedy, or a combination, could get us going again because of the competition that is out there, particularly from China. But I don't see anybody right now recognizing that's the issue. That space is as geopolitical an issue as anything going on in this world right now. It's eminently tied up with our national security, and it's tied up with our national psychology too, I think, and the world psychology. And we just need leadership that will recognize that. How about this young man back there?
I just want to know what it was like to launch on a Saturn V.
Okay. Well, I'll tell you, it's exciting. Once we got going, we had a 2-hour and 40-minute delay because of a launch computer, and the rocket didn't quite agree on its status. This rocket was fine. The launch computer just didn't know it. But once we started, when those 5 F1 engines in the first stage of the Saturn V ignite, you begin with extremely heavy vibration. If you know an abandoned railroad track that still has the ties, and you know someone with an old pickup that they're willing to drive down that railroad track, you'll get a feeling for what that low frequency vibration was, of these 5 engines interacting. And then gradually the acceleration builds up, but very slowly at first. And it takes 2 minutes and 45 seconds to get to where you're at your maximum G load, which was for us was 4.5 Gs. And then at that point, when you reach maximum Gs, the first stage engines have exhausted all their fuel, so you turn them off. Then you stage, and you ignite the second stage. There are 5 what are called J2 engines. The first stage engines are kerosene and oxygen. The second stage engines are oxygen and hydrogen. Now that sequence takes you from 4.5 Gs to a minus 1.5 Gs because the whole rocket unloads for about a second. And then a plus 1.5 Gs. And that all goes in about a second. And that gets your attention. You know why they strapped you in so well, okay? In fact, strapping us in, the guy comes in there with us, and he stands on your chest as he pulls these straps down. And tell you, if you weren't strapped in or you don't have everything stowed, that sequence is going to get pretty violent. But then everything's smooth. The second stage engines are very smooth, and the third stage, S4B, is just one of those engines, and that, of course, is one of it's the last kick you need to get into orbit, but it also is a restartable engine. So that's what you use to accelerate to get you on a velocity that'll take you to the moon. When you're in orbit around the Earth, you're going about 18,000 miles an hour, a little less than that. And to get on a trajectory to the moon, you need to accelerate to about 25,000 miles an hour. Now, of course, you don't notice that because there's nothing going by. But it's an experience. I wish we still were making them, I'll tell you. I really wish we were.
With that great answer, let's thank our speaker.
Yeah.